let's take a look at the last part of 2.2. So we've looked at how to find the coordinates when it's a 0, 90, 180, or 270. Those are the four easy ones. We've done the 30, 60, and 45. Now we're going to look at finding the trig functions of multiples of 30, 60, and 45. Okay, so multiples would mean numbers like 30, 120, 150, 210, 240, things like that. Multiples of 45 would be like 45, 135, 225, 315. So we're still using the same triangles. They're just going to be reflected into different quadrants. Make sure we remember what those are. So for the 45, 45, 90, each side is the same. Can somebody tell me how long each side is in the 45, 45, 90?
Mm-hmm. How long each side?
Yeah, that triangle. It's parts of the coordinate for the 45. Yep, that's one of them. And the other one? Same thing. So the coordinate, when we're dealing with anything that's a 45, is going to be a root 2 over 2, comma root 2 over 2. How about the 30, 60, 90? What are the two side lengths in that triangle? 1/2 and square root of 3 over 2. And which one is bigger? The square root one is bigger, right? Square root of 3 over 2. If you divide that out in your calculator, you get about 0.86. 1/2 when you divide that out is 0.5. So square root of 3 over 2 is the bigger number. 1/2 is the smaller number. That's all you need to remember to do all of this. Just those three numbers. That's why there's really nothing else for me to explain. I'm just going to jump right into an example. Okay, so we want to find the 6 trig functions of 135. First thing we have to do is decide where 135 is. You're going to have 3 choices where it could be. It's either going to be right in the middle, closer to the y-axis, or it's going to be closer to the x-axis. If it's closer to one of the axes, it's a 30-60 problem. If it's right in the middle, then it's a 45-45 problem. So 135 degrees. So where would 135 be? I know it's in the second quadrant.
Right in between 90 and 90.
Yeah, it's exactly in the middle. Okay? It's exactly in the middle. So let's make our triangle. And we just said, because it's right in the middle, that means what triangle is this? The 45-45 or the 30-60? It's the 45-45 because it's right in the middle. So 45, 45. You don't have to worry about positive and negative at this step. Just tell me how long is each side in the triangle.
Square root of 2 over 2.
Yep, they're both square root 2 over 2. So now we know you have to go left, square root 2 over 2, and up, square root 2 over 2. We have to take into account we're going left. So what does that mean about the x value of my coordinate? It's negative because we're going left. And what's it going to be? Negative, how much do we go left? We go square root 2 over 2. So the x value is negative. And what about my y value? That's positive because we went up. Square root 2 over 2. Okay, now that we have the coordinate, everything is the same as we learned yesterday. The only difference in this problem is the x is a negative. So let's go all 6.
So is that just all this?
Yep.
It's all going to be the same.
Yeah.
Flip,
What quadrant is it? Yeah. I'm not going to go through all 6 after this one. I'm going to pick one trig function because that's how it's going to be on the test. So we're only going to do one. For this one, I'll do all 6. Okay, so Dominic, what letter is my sine? What's the formula? Sine is my y, and what's my y here?
Square root of 2.
Yep, it's the positive one. Okay, so there's the sine. Kiana, what's my formula for cosine? It's the x. Yep. And what's the x in this case? Yep, negative square root 2 over 2. Austin, what's my formula for tangent?
Y divided by x.
Y divided by x. So we're going to take these two things and divide them. So just imagine like putting a division line right there. But y and x are the same, except one is negative. So it's like they're opposites. So what do we get when we divide two numbers that are opposites?
-1.
Negative 1. Positive divided by negative is a negative. So that's going to be negative 1. Curtis, what does that mean by... Well, let me ask another question first. What do we do for these to get those? Yeah, we're going to flip these to get the other 3. So what do you get if you flip negative 1? And that would be my what? That's my cotangent. It's the only one that doesn't have a square root. Okay. Tony, what's my first step to get the cosecant?
You flip the sin.
Yep, flip the sign. And what do you get when you flip that?
2 times the square root of 2 over 2.
Okay, so he flipped it and he started to fix it. So he got the square root back in the top. And then what's going to happen there? One more thing's going to happen.
You got 2's.
Yeah, the 2's are going to cancel. So all we end up with when we flip the sign is square root 2. Cameron, how about my secant?
Will this be negative square root of 2?
Right, it's just going to be negative square root of 2. It's the same as the sign, but with a negative in front. And there's your 6 trig functions for 135. Okay. Any questions on how we got the coordinate or any of the 6 functions? Okay. Let's try this one. Cosecant pi over 4. Again, I think most people are going to find it easier if you change to degrees. So what is pi over 4 in degrees, yeah?
45.
It's 45, so this is really a problem we did yesterday. Let's decide where that's going to be. It's definitely in the first quadrant, but is it closer to the y-axis, x-axis, or right in the middle? It's right in the middle. Because it's right in the middle, how long is each side in that triangle? They're both the same, and what are they? Yep, they're both square root of 2 over 2. So those two numbers are going to tell you what your x and y are. And because we're in quadrant 1, both the x and the y are going to be what kind of number? Positive. Both positive. Okay, so now we want cosecant. We should know which one to flip, even though if you pick the wrong one, you'd still get it right because they're the same. But if you're doing cosecant, which one do you flip? You flip the y. So when we take the y and flip it, we get 2 over root 2. And we just did that on this one, square root of 2. Any questions on how to get square root 2 out of there? Okay, so 2 things I'd look for on the test. 1, give me the coordinate. 2. In this case, I wanted the cosecant. Yes.
Can you show me that how you have it to?
How we got the square root of 2?
Yeah.
So if you take the original answer, and you don't want to leave the square root in the bottom, so multiply the top and the bottom by the square root, and then go straight across. In the top, it's 2 times the square root of 2. And the bottom is square root of 2 times square root of 2, which is square root of 4. But the square root of 4 is just 2. And then your 2's cancel out. So you're just left with square root of 2. Don't cancel the 2 under the root. You can't do that. But you can cancel the 2's that are outside the root. Like that. Okay, let's try this one. Sine of 225. So, Sam, where do you think that one... First, can you tell me what quadrant that one's going to be in? Let's just get kind of a rough idea.
The third quadrant.
Yep, it's the third quadrant. Remember, this is how you number. So it's going to be in the third quadrant. Closer to the x-axis, y-axis, or right in the middle?
Closer to the x-axis. No?
Well, let's see. This is 180. And that's 270. How far away from 180 is 225?
45 is in the middle.
It's 45 away, so it means it's right in the middle. That's 225 right in the middle. And Sam just said it's 45 away, so that means this is the 45-45 triangle. So the numbers again are root 2 over 2. Root 2 over 2. And those give you an idea of your coordinate. In this case, they're not exactly the coordinate because we're in quadrant 3. So Ryan, what's going to be my coordinate for 225?
It's negative square root 2 over 2, negative square root 2 over 2 over 2.
So they're both negative. Okay, and what's the definition of sine? Looking for a letter here. No, an English letter, not a Greek letter for this one. Yeah, so no, English letter.
Yes.
No, not S. Jenna, can you help him out?
It's Y.
It's Y. So the definition of sine is the Y value. In this case, the Y value is negative root 2 over 2. Sine and cosine are the only two. You don't have to do any arithmetic. Okay. Any question on that? Okay, so we did a 45 in quadrant 1, 2, 3. Well, let's just do the last one. 45-degree angle in quadrant 4. Before I show it to you, does anybody know what it would be? Yeah, so the coordinate is going to have a positive x and a negative y. But what's the angle going to be? Yep.
315.
Yep, it's going to be 315. So if you didn't know that looking at this problem, the first step would be to convert 7 pi over 4 to degrees so you can figure out what it is. And if you multiply 7 times 180 divided by 4, you will get exactly what Curtis said. If you type it in the right way. 315. Okay, so 315, that's exactly 45 degrees after 270, but it's 45 degrees before 360. So it's right in the middle. They're not always going to be right. Okay, we're gonna do some next that are not. Okay, so we got our triangle. We have to figure out how far to the right and how far down we go. Those two numbers should basically come from just memorizing them. You go right root 2 over 2. You go down root 2 over 2. If you forget them, then you have to figure them out from scratch again, the way we did yesterday. That starts to take a long time. Okay, so what is my coordinate for 315? Root 2 over 2. Negative root 2 over 2. And they want the cosine. So cosine, Naija, what's the formula for cosine?
Oh, that's the X.
That's the x, and what's the x in this case?
Square root of 2 over 2.
Square root of 2 over 2. Yep. So there's a 45-degree angle in every quadrant. Any questions on the 45s? So if I put it all in one diagram, this is basically what we've done. We did every one of those triangles. Now there's two other points we can do in each quadrant. We can do the 30, which is the one closer to the x-axis, and then we can do the 60, which is closer to the y-axis. So now we're not going to do all of them because there's 8 of them. There's 2, 2, 2, and 2. So let's just pick a couple of them and try. Okay, tangent of 120. All right, so first thing, let's just figure out what quadrants we're going to be in. 1, 2, 3, or 4. Tyler, can you tell me what quadrant is 120 in?
3 or
So 3 would be down here, not that far.
Right between 80 and
Which one? 2, yeah. It's quadrant 2. So this is 180. That's 90. And now we're going to figure out where 120 is. It's either going to be closer to the 90, closer to the 180, or it's going to be right in the middle. Where's 120? It's closer to 90. And I would even exaggerate it, make it probably even closer than it really should be. But put it just a little bit past 90. Okay, so there's my 120 degrees. Okay, make your triangle. Always draw to the origin, and then you draw straight down or up. Depends where you are. Draw straight down. Okay, is this going to be the 45-45 problem or the 30-60?
30-60.
This is the 30-60, which means you've got a short side and you've got a long side. So now we have to get them. We have to get them right. Let's start with the short side. What number do we always use for the shorter side? Yep. There's my 1/2. Yep. And what number do we use for the longer side? Yep.
square root of 3 over 2.
Square root of 3 over 2. Okay, so we've got both our numbers. Now we need to put them together to make the coordinate, taking into account we'll go left and then up. Alright, so Jackson, what's going to be my coordinate for 120 degrees?
For both of them next and one.
Yep, the whole coordinate.
Negative 1/2.
Yep.
Square root of 3 over 2.
Perfect. Okay, so there's my coordinate. And how about My formula for tangent, I gotta do a little work to get this one. Yeah.
That's part of the third. Wouldn't it be flipped?
If that's part of the what?
No. That's, for my thing, that's 60.
Well, this is the one where the 60 is down here. The 60 is down here, and the 30 is up there. So it's where it's standing up taller. You might be thinking of the one where it's looks more like this. That's where the long side is on the base.
Yeah, no. I was just confused about X.
You okay with them now? Because when we draw it, the bottom side is the short side, and the tall side is the long side in this case, the height. So the bottom side, since it's shorter, is always the smaller number, the 1/2. Since the height is the longer side, it's the longer number, but we call it the bigger number. And for tangent, what's my formula? Yep.
Square root 3 over 2 over -1.
Yep. So my tangent is going to be y over x. Okay, I'm going to divide them. Dominic, when I divide them, what cancels out? 2's are gone. And what am I left with?
-3 and negative square root of 3.
Yeah, you're just left with the negative square root of 3. And that's it. So here's your coordinate. Here's your answer. Question on that one? Let's try. I think I got one more. Well, I got two more. We'll do one more, and then if people want to see another one, we can. If not, we'll go on to using calculators. Secant of 690. Well, it's in degrees, so we don't have to worry about changing it to degrees. But we might want to do something with that 690. Yeah? Let's subtract 360. So if we take 690 minus 360. Oh, sometimes it doesn't register that I pressed the button. We get 330. It's a little easier to think about. Okay, so 330. Well, Gavin, where's 330 going to be? Start with just the quadrant.
Let's see, it would be in the fourth.
Yeah, it's going to be in the fourth quadrant. And this is 270. That's 360. Where's 330? Closer to 270? Closer to 360? Everyone agree closer to 360? Yeah. So let's put it here. Yep, draw your triangle. And it doesn't have to be perfect, but if you draw it somewhat reasonable, you should be able to tell which side is the short side and which side is the long side. There's your hypotenuse. And there's your other side. Okay. Jenna, how long is this side that I just traced over and made bold?
Square root 30 over 2.
Yep, that's my long side. And how about this side? About 10. 1/2. Okay, so we got the two numbers. Now we just got to get the positive, negative correct. Austin, since I'm in quadrant 4, that means I'm going right and then down. So what kind of number is my x going to be if I go right? That's going to be positive, so my x is root 3 over 2. And what about my y?
Negative.
It's going to be negative because we go down. Okay, so there's my coordinate. And now they want to know the secant. So Grady, when we do secant, Which one do we flip?
Is it the X?
Yep, it's when we flip the one that would be for the cosine. So it's going to be 2 over root 3. And when I fix it, Sam, what's that going to fix so the root goes in the top?
2 times square root of 3 over 3.
Yep, 2 times the square root of 3 over 3. Good. Okay, so there's 8 different problems we can do that end up being a 30 or a 60. One just before the 45 and one just after it in each quadrant. Is there any questions, or does anybody want to see how to do another one that's a 30-60? This would be a 30-60. Any question on how you would start that? You would convert it. And when you convert it, you're going to get a negative number in degrees. I can tell you you're going to get negative 210. One I can do in my head.
So just add 360 to that.
So you're going to want to add 360 to that. And when you add 360 to that, you get 150, I think. All right? Okay. 360 minus 210. Yeah, 150. So now you've turned it into this problem. Any question how you would do it from there? All right, so I'm going to show you basically a diagram that has every problem on it at the same time. So it's going to look like a lot of stuff. But remember, it's really just same numbers repeated in every quadrant over and over. But this summarizes the pattern of everything we've done. We're not going to copy this whole thing down. Okay? But all the red ones, those are all the 45-degree angle problems. And those are all the root 2 over 2s. Sometimes they're positive, negative, or one of each. All the green ones are the 30-60s, where the long side is the base. So the root 3 over 2 is the big number, and that one comes first. Only difference is sometimes it's positive, sometimes it's negative. And then the blues, those are all the ones where the 30-60-90 is standing up taller in every quadrant. When it stands up taller, the y value is the big number. And that's why it comes second in all the blue ones. So if you count it up, there's 3, 6, 9, 12. Those are your 30, 60s, and 45s. And then 13, 14, 15, 16. So there's 16 different points that we studied on the unit circle. And notice there's a gap. We didn't do this one, and we didn't do that one in every quadrant. Those are the 15s, like 15 and 75. It's just not something that we look at in this class. All right, but that summarizes, that's unit circle trig right there. So unit circle trig covers 16 different angles that we've learned how to do. But there's a lot more angles you could have on this circle than 16. You could have 333 or 274. Okay? There's a lot of other angles we can have. If you end up with a problem and the angle is not a multiple of 30 or 45, you're not going to be able to use this diagram to figure it out. So what we're going to do instead, we're going to use the calculator. When we use the calculator to evaluate, we're going to get a decimal. Decimal is perfectly fine here. In fact, for most angles, if you told me to not use a decimal, I wouldn't know how to do it. So you have to use a decimal to get the answer. The 15s and 75s, I would know how to do. That's a little bit different. Okay, but when it's not a 30 or 45, we're going to try it on the calculator. Okay, we're not going to do all 6. We'll practice one trig function per problem. Right, let's start with this one. So this symbol means what we're going to put here is approximately the answer. It's not an exact answer. It's going to be round. Can someone read to me what does example 8 say? Not the direction, not a value, the problem. Sine of, and the last word you said was important, sine of 18 degrees. You see that symbol right there? It's basically telling you to turn on your calculator, press the mode button, and make sure you are in degrees. If your calculator is in radians, then you're going to be doing the sine of 18 radians. That's a totally different problem. So you turn it on, put it in degrees. If you switched it to degrees correctly after you press the mode button, it should say degrees at the top. If it still says radians there, then you have not changed it to degrees. Okay, any question about putting it in degrees first? So I'm not saying every problem is going to be in degrees. I'm saying you need to read the problem, and if you see the little circle, put it in degrees. And then just type it in. So sine 18, and then close your parentheses, just like that. Hit it. So that's the answer of sine of 18 degrees. The test will tell you how many decimal places to round to. For us, it doesn't say, so let's just do 0.309. Okay, any question on how I got 0.309, or did anybody not get that to try to do it? Yeah.
What if you don't switch it into degrees?
Then it'll be wrong.
Well, like, wouldn't you just have to switch the degree to a radian? Okay.
So like if you're saying if you left it in radians,
Then you switch the number it gives you to radians.
you could. So now you could manually convert that number to radians. You're introducing another step that you could make a mistake in. So I definitely would not do this, but you could leave it in radians and do sine of 18 times pi divided by 180. And I get exactly the same answer because I took the original problem and changed it to radians. But the easier way to do it is just put your calculator in the mode for the problem. Then you don't have to do that by hand. Does that answer your question? How about this one? Tyler, what does that one say?
Cosine of 36.
Can you be more specific?
What? Oh, degrees.
Degrees, right? There's a difference between cosine of 356 and cosine of 356. So I switched to radians, so I need to go back to degrees. And we just type it in. So cosine 356. Okay, when you try it, you should be getting 0.998 if you're rounding. You might also notice that this number is starting to get close to something. It's starting to get very close to 1. And if you went all the way to 360 with that number,
Would it be 1?
it would be 1. Yep.
Would it be 1 for every one of them, or just that one?
Just 360. If you go past 360,
No,
it
I
starts
meant
going
for
down.
each of the different signs.
Oh, like the sine, cosine, and the tangent?
Yeah.
No, they all come out different.
Yeah, I was gonna sign and change to 0.
Yeah, the sine of 360 is 0, the cosine of 360 is 1. Okay, what about this one? What does that one say?
2.4 radians.
Tangent of 2.4 radians. You don't see a degree symbol here. That's how you know it's radians. So go to mode, put it in radians, and type in tangent 2.4. So we get negative 0.916. If you did not get that, then you put something in wrong. Any question on that? Now, as far as the buttons go, well, that's it. It's the only 3 buttons we have. Sine, cosine, and the tangent button. So how are we going to do cosine?
Is it the ones above it that have the little -1?
So there are these little numbers above it that have these little -1s. We're going to talk about what that is next week, but that is not what we want to use. But that is important for something else. But it's a good guess. You would think the -1. Usually when you put a -1 on something, it means to flip it.
So what's that used for?
It's inverse trig. It's used when we want to figure out an angle. We're not figuring out an angle here. We're being given the angle. Inverse trig would be kind of like if I gave you this number and you had to work backwards to get the 2.4. So it's the reverse of these problems. But I'm giving you the angle. Anyone have another thought how we're going to do cosecant? How have we been doing it?
You flip whatever your other number is.
You flip. Can you be more specific? What do we flip to get the cosecant? Well, if we could come up with a coordinate, it would be the y. But the y is which trig function? Yeah? The sine. So the only way you can do the cosecant is to take the sine of that and flip it. And this is how you do that.
1 divided by it.
Yep, 1 divided by that's how you flip it. Now, if I hit enter right now, I am going to get this wrong. Anybody see what I need to do? I haven't hit enter yet, so I can still do this.
You put parentheses around the 1.
No, I've typed it in fine. You don't have to put parentheses around the 1. You could, it won't hurt anything, but you don't need it. But there is something I need to do or this is going to come out wrong. Yep.
It's still in radians.
It's still in radians. And this problem says degrees. If you leave it in radians and you hit enter, it'll give you an answer. It's just that is not the answer we're looking for at all.
That's like the opposite of the answer I got though.
So put it in degrees, hit enter, and you can see they're not the same number at all. Okay, negative 1.086. Okay, so that's how you do your cosecant. All right. How about this one, Ryan? What does that one say?
We do 1 over the cosine one.
Right.
But that's radians.
So that's radians. So we gotta fix that first. So it's in radians. So let's take care of that. If I had a bunch of these on the test, I'd probably go through all the ones that are in degrees first, and then do all the ones that are in radians, so I don't have to keep switching back and forth. Okay. Now I'm back in radians, and you said to do 1 over what?
1 over secant 1. Right on.
Well, that's the secant, but we don't have a button for that.
1 over cosine.
1 over cosine. And close your parenthesis. Okay, so 1.041. Okay, and these are all problems that you wouldn't be able to get the coordinate for. 247 is not a multiple of 30 or 45. So you're not figuring out coordinates for that. And the cotangent of 13. Well, first thing, is 13 a multiple of 30? No. 30 times 0 is 0, 30 times 1 is 30, so 13 is not in there. Is that a multiple of 45? No. So then we're going to have to use the calculator. All right. What's the first thing I should do on my calculator? I need to change back to degrees. So mode. Put it in degrees. Okay. And how am I going to type that in to get the cotangent? Sam?
Sine of 13 degrees over the cosine. No, the cosine over sine.
No, you were right the first time. I wasn't expecting someone to say that. But what you said there will work perfect. When you take sine, oh no, I'm sorry, what you said the second time was right. I was still impressed with your answer the first time. I wasn't thinking. So he said take the cosine divided by the sine. Yes. So 4.33 is the correct answer. But is anybody thinking of a different way? Other than cosine divided by sine?
Can we just do 1 divided by the tangent?
You can just do 1 divided by the tangent. And you will get exactly the same thing. Because cotangent, remember cotangent is x over y, right? If you think about it as a coordinate. But the x is the cosine, and the y is the sine. So if you take the cosine and divide by the sine, you can get the cotangent that way. But an easier way to do it is to just take the tangent and flip it. But both ways work. We're going to talk more about things like this, like 6 or 7 weeks from now. Formulas that you can do things like this. Different ways to get things in trig. But if you notice that, that's really good. Okay, any questions on that? All right. So put up the homework. And put a list of topics that are going to be on the test. All right. So first thing, let's see. You might have some problems where I give you a coordinate and then ask you to find a trig function. It's the very first type we started out with. I gave you a coordinate, you figured out the trig function. The next type we get is you have to find the coordinate yourself. That's most of what we've been practicing all week. Find a coordinate and calculate trig function. Okay, we did a lot of that today. And the last thing that's going to be on there is use the calculator to evaluate trig functions. Now, if I ask you to find a coordinate, then you know that your angle has to be a multiple of what two numbers?
30 or 45.
30 or 45, one or the other. If you're using a calculator, then obviously it's not a multiple of 30 or 45. so that's everything that's going to be on the test. Okay, so section 2.3. I will be after school today, so if anybody needs to stop by to make something up or get some extra help before the test, I'll be here. Otherwise, you've got a little over 15 minutes or so. You could start the homework. 67 to 81, those are all calculator questions. I just erased 83 and 84 because that's something you don't need to know. So, yeah, get rid of 83 and 84. You don't need those two.